Jako pierwszy w tej sesji wystąpi przed Państwem dyplomowany inżynier budownictwa i inżynierii środowiska z dorobkiem naukowym i praktycznym, obejmującym blisko 60 lat pracy w zakresie projektowania i naukowych podstaw systemów wód miejskich. Laureat wielu nagród, autor ponad 600 publikacji. Richard Ashley.
Good afternoon. I hope you enjoyed your lunch and not too many of you fall asleep for my presentation. So, we have heard a lot about blue-green in Poland, and it's becoming the norm. It's no longer let's go straight to the drain. But what is a drain? And if you read in various regulations and definitions, the drain conveys water away quickly, safely, and securely. In the UK, it's called to effectually drain. But that's not what we are about here. But stormwater is a Cinderella in the urbanism landscape. Most politicians are only interested in it when it causes problems. Increasingly so, but still, actual genuine attempts to tackle issues to do with stormwater are few and far between amongst our governments and even the institutions charged to manage it. Even within the EU, stormwater is not seen in the same light as river flooding. Sewage, of course, is much easier to define. It's heavily polluted. And stormwater is shared between different organizations in terms of its management. And it's very dependent on urban planning. So it's also seen as a problem rather than an opportunity. So the journey we're all on, because we're here, stormwater is a minor consideration that we need somehow to raise up the agenda. And suddenly everyone's talking about nature-based systems. You see it everywhere. It's in documents all over the place. But we've still got our legacy of buried infrastructure. We cannot just abandon that, particularly in Europe. And the costs of maintaining it and adding to it, if we so desire, are prodigious. So we have to move stormwater up the agenda, whether they like it or not, and present it to the governments and institutions as an opportunity. So we need a culture change. And one of the ways in which we need to change is to introduce an adaptive culture. So that means trying things and changing. In the Netherlands, for example, the big coastal defense projects are very much about adaptive planning, about doing something, seeing how it goes, and then building on that. And we need to try and do the same thing with surface water management. Fortunately, blue-green infrastructure is easier to adapt than buried pipes. More of that later. So that physical, technical bit, we can understand. But changing the regulatory regimes, and we had a discussion of that just before lunch, is often one of the biggest obstacles. So what about designing our drainage? And Ulrich earlier showed a similar approach to this one. And this is in one of my co-authored publications on exceedance drainage. And what we have are the lower events, the lower volume events at the bottom in zone 1. We have our design events in zone 2, and we have exceedance events in zone 3. Exceedance event is an event above your design rainfall. In the UK, typically we design BGI systems for 1 in a 100-year event, so it would be something bigger than that. We've then got extreme rainfall. In each of these zones, 1, 2, and 3, even when our nature-based system is exceeded, we can utilize opportunities for the surface water. And our resources fit very much in zone 1, where we would look at sequences of rainfall to take the opportunity. Of course, it also goes back to individual properties. And again, we heard before lunch about developers and how developers are often reluctant to change to a system that would actually do with water what the opportunities allow us in terms of resources. And the opportunity, of course, is to utilize the rainfall where it lands or as close to. So at one end we have that, a domestic system. We also heard about potential for grey water use before lunch. And I want to start really with a couple of slides of axioms. So initially, our planned approach should be to integrate our surface water systems with land use planning and across other systems. We understand that. To cope with climate change, take a managed adaptive approach, which I've already mentioned before, promoting flexibility and diversity of systems. Resilience is very much about diversity. Use the right technology in a risk-based approach, which I think we are doing, and a combination of nature-based systems and traditional pipes. We will always need traditional pipes. Utilize intelligent systems and maximize opportunity and multifunctionality. My second slide of axioms is about managing our systems appropriately. Operation and maintenance as important as new build. In the past, people have built and walked away. You've built a pipe, drainage system, and then you walk away because you know it will operate for at least 100 years. Many in Europe are operating even longer than that. And you don't think about the maintenance. We can't do that with BGI. We have to keep an eye on the operation and who's responsible for maintaining. So we need to understand the asset management needs and methods across traditional and nature-based systems. How do we manage those assets? Use AI opportunities and make the case. And it's a cultural change. And in my professional life of 60 years, it's been fellow professionals that I've had fights with more than anybody else. Persuade many groups, make business cases, and there's more than one business case needed. And then we need evidence to show performance. Earlier we heard about the need for pilot projects. So we need to get to the point of selling it. We live in a neoliberal economic world, like it or not, becoming more neoliberal by the day. So how do we sell this? Well, this is near me in Dundee, Scotland. And if we're going to do this, and this is a multifunctional space, we do need the space to do it. How do we do this in dense urban areas? And in Dundee, they've got a green network, it's interconnected. That's the big plan. Install BGI and make sure it's coherent within the planning framework. So what I'm going to talk about now is economics. We've hardly touched on economics so far. Making the business cases. And I was involved in a European Interreg project called BEGIN, Blue-Green Infrastructure, which was all about the business case for blue-green infrastructure. And then we're going to touch on whether is it sustainable. If we'd gone back to before your 10 years ago, a lot of people would have been talking about sustainability. That is a dirty word now. It's been dropped. People forget about it, but I'll come back to that. So we need to make the business case. And we need to look at cost-benefit analysis. And yes, it's only the Anglo-Saxons that are interested in cost-benefit analysis, as I've been told by the French, that it's only really us Brits that are obsessed with cost-benefit analysis. And that's what I'm going to talk about. How do we value nature? These are a couple of projects I mentioned. BEGIN, enabling water-smart communities. That's a British project that I was involved in last year. And we actually talked to communities. How much more would you be willing to pay for your new house if it was in a green area? And people were willing to pay more. They had other things on their mind about crime, for example. So obviously in the UK, crime is out of control. And the basis for this is ecosystem services and natural capital assessment. So we all know that in around the year 2000, we had an artificial intelligence revolution. But we also had the Millennium Ecosystem Assessment, where the world effectively agreed on the price that we could put on to ecosystems for their value to humanity. And that's what this work is built on. And for example, the value of natural capital in England, not the UK, in England, estimated as 1.4 trillion in 2020. But bringing us back to our BGI, what could we do? What's possible? Where is the value? And there's a whole range of values here. We've heard earlier about increased property prices, obviously water resources, but there are other things like traffic calming. In the US, they build what they call bump outs. That's rain gardens on the sides of roads that also slow traffic. So we're going to look at some of these and what they're worth. But before we do that, the first ever application of this concept in the UK was in London. And it was in an area of deprivation. And therefore, investments gave a very good return. And the problem was flooding, and there was a local park, but it was flooding adjacent properties. And it was decided to invest and look at the value of the benefits that might come from ecosystem services, from investments. And it was discovered that the benefits of investing £1 were £7. And 93% of the benefits were for cultural services. So in the ecosystem services categories, there are 4 groups of benefits. Cultural services are far more to do with community value. And this was accepted by the British government as a justification for investment. Philadelphia has been a path-finding city for doing this sort of stuff. Combined sewer overflow problems. They have approached this as a green city type approach, but not for the whole city. 50% of the combined sewer overflow problems were being tackled by the LID, Low Impact Development, or BGI, and this has been underway now for some decades. And you can see increased recreational opportunities, the value to the city, $524 million US. Improved aesthetics, property values, which we call amenity, $574 million. Reduction in heat stress mortality, $1 billion. And you end up with a total of $3 billion by using blue-green infrastructure as the added value. And all this added value went to the mayor and the mayor's office, because the mayor in Philadelphia was responsible for all of these services. So the justification was very high for this investment. I don't have the costs, but the question then is, who pays and who benefits? The people of Philadelphia are benefiting, the municipality is benefiting, and therefore they should pay. And it was a tool developed by the Center for Neighborhood Technology in the US that was used to determine these benefits. Now, I'm the co-creator of the UK equivalent of this, a tool called BEST, Benefits of SUDS Tools. As you know, in the UK, they use the term SUDS, Sustainable Urban Drainage. They're not necessarily sustainable, as we'll see later. But this tool, BEST, puts monetary value on these various multifunctional benefits. So here we have air quality, pounds per tonne of pollutant reduced, amenity, primarily house price values, biodiversity and ecology, building temperature, carbon reduction, education, flooding, groundwater recharge, health. Health is often one of the big ones. Rainwater harvesting, recreation, treating of wastewater and water quality. All these we've monetized. And this is what the front end of the tool currently looks like. It's on a GIS platform. Anybody can access it, although you have to pay £500. So I'm not going to go into that. But how does it work? It works via what we call impact pathways. So what are you planning? How will the infrastructure work? What will it change? How much will it change? What is the final outcome? And what are the benefits? For example, new park areas, planting and soil, quantity, quality, amenity, and this is proportionate to the size, number, and context. And I'm going to give you some examples. The city of Bradford, which is a multicultural city, it's Cultural City of the Year in the UK at the moment. And it's an inner city area that they wanted to retrofit rain gardens. And this is what it looks like, very dense. And this is what the street rain gardens look like. And we were asked to look at the value of doing this. And the net present value, that's the benefits minus the costs, discounted over 25 years, gives a ratio of 1.6. And the health benefits were the most significant, as you can see there from the list of benefits. So this is the quality of place. There are increases in property value in there. George V Park, local flooding, significant to cause a lot of disruption, but also problems for people living there. Utilize the park by building BGI. And so we were taking a green space, but we were modifying it. And our conventional drainage, these are cost benefits and net present value. The green is the net present value. Conventional drainage, it's a very small figure. If we modify the park and put in 7 trees, the net present value goes up to just over £300,000. If we use 25 trees, it's not much different. Trees actually are quite significant in terms of added value. And this was part of another European project. So understanding that value, you say, well, these are a couple of small, one's a town project, one's one where there's a park already. Okay, sewer overflow problem. Some of the people here told me last night they'd lived and worked in Leeds, and this is a Leeds case study. And the objective was to manage surface water runoff to ensure clean habitat for white-clawed crayfish. So it's a water quality project. So what was possible? Combined sewer overflow storage tank before discharge, an excess-sized tank to manage flooding downstream as well, SUDs in public spaces and SUDs in public and private spaces. And I'm only going to look at one option, SUDs in public and private spaces. The highest value was the elevation in property prices from retrofitting BGI. Water quality is a smaller benefit, and that was our objective. And if we look at the net present values, the green bars, they're all negative apart from SUDs in public spaces. But that's not the real issue with this case study. The real issue is that the costs of using BGI are 3 times the costs of building a tank. Okay? So who should pay in terms of the costs of getting the added value from the BGI? And this is a private water company we're talking about in England. And despite the main objective to improve the river water quality, the main benefits are for amenity, property prices, and flood risk reduction. And this is just some of the numbers, but I think I'm not going to have time really to go through that. The main point of this case study is that should the water company pay for added BGI benefits when it doesn't benefit as a service provider? So who benefits and who pays? And these tools are now enable us to ask the questions, who benefits and who pays? And I said I was going to touch on sustainability assessment. So it's never been developed properly. There are a lot of guides on sustainability, but no one can quite agree on how to assess it. But we can compare one option with another. So this is my book on sustainable water services. And the criteria cover economics, social, society, and environment. And this is a case study from Sweden, because I'm an adjunct professor in Luleå. And the question was, which rain garden is likely to be the more sustainable? And I know you're using a lot of rain gardens. So we actually looked at 12 rain gardens of different types of design, all to the same results, all controlling water quality, primarily. So it's a pollutant removal, but of course they provide other benefits. I've mentioned the traffic control. So 12 of these with different shapes, some concrete, some with different fill material, and postdocs and PhD students worked on this with me, and there's journal papers published on all of this. So life cycle analysis, looking at the key components of the actual pollution caused by the materials used in the rain gardens, the concrete and the fill material in particular. And human toxicity, freshwater ecotoxicity. And again, we don't have time to go through all the detail, but I'm just contrasting this with what I've shown you about the business case from the economics. And of course, there are big impacts from the installation, the production of the materials, and the construction. So concrete, filler material, transport distances, some of which had to be shipped into Sweden. And we applied the best economic tool in the Swedish case. Many benefits actually are negative. In other words, the costs outweigh the benefits. And it's possible then to come up with a visual assessment of sustainability. Comparing the different options, you can see all the numbers around there. And what we discovered was there was no one type of rain garden design that was any more sustainable than another. The problem is that you've got very many criteria, and some were better for some criteria and some were better for others. And we should be looking more to the future than we are. It's no good just saying we're going to get uplifts to climate change on our rainfall, that the developments in this area are going to look like this over 25 years. There's a lot more things changing. Numbers of people, society's expectations, deterioration and maintenance needs. Who will do the maintenance in 25 years' time? And this is really important for our BGI systems. People's needs and who will own and operate the system. We should be using more scenario planning. And I've been talking about this for years, but it isn't really getting through. And, as I said, managed adaptation pathways. And this was another one of my PhD students, but this is West Garforth near Leeds. And this is a managed adaptation analysis of flooding, essentially, what, if, and then. And finally, I've hardly heard it mentioned in this talk. I was asked to look forward. AI, like it or not, it's here. And this is an extract from my latest book, case study. Sorry, it's in black and white, but this is a green-blue roof that's smart. And the AI maximizes the storage available before the storm comes. It also makes sure that the green, and I'm sorry it is black and white, is kept properly irrigated. And the AI makes these decisions automatically on this green-blue roof. But it's not just AI. Everyone in this room should be getting out there, working on your projects, putting your boots on, getting out there. AI will never replace you getting out there, standing in the mud and the rain. Increase the need for cross-disciplinary delivery, operation and multifunctionality. AI will certainly do that. And many new opportunities will arise from adjacent sectors. A lot of what we do has come out of the electronics industry. Hundreds of years ago, when I started my research, we didn't have sensors. We didn't even have computers when I was a student. Yes, I used the slide rule. And all that has come about in my lifetime. So our biggest challenges, and I'm winding up, is coping with legacy infrastructure. Like it or not, the sewers that you've got out there are going to have to be maintained for a long time. When do you use passive systems and when do you use smarter systems? We're hearing a lot at this conference about poor governance and institutional arrangements, and England can't talk about that. It's got one of the worst governments and institutional arrangements in the world. Lack of integration across services. And water and drainage are not interesting to politicians, and our budgets will always be constrained. And then finally, I'll leave you with this image from one of my Sheffield colleagues. They have a huge program on robotics in networks, in sewers, water mains, and what they've developed is autonomous robots. These robots spend their whole lives inside the pipe network, making their own decisions where they go and relaying back the condition that they find. This will, in your lifetime, become normal. Thank you.